Okay, Assalamualaikum and very good morning to my lecturer and friends. First of all, I would like to thank my beloved lecturer, Sir Ganigapur bin Muhammad, and my fellow friends. So before we start the presentation, I would like to introduce myself and my team members. So starting from me, my name is Alif Amir Adli bin Hisham. My metric number is 01DKA2C F1094. And for the second member, we have Shoban Rao, son of Iswara. His metric number is 01DKA21F1092. And the third member is Muhammad Haikal Hakimi bin Desa. His metric number is 01DKA21F1093. And last but not least, we have Muhammad Azmil bin Musa. His metric number is 01DKA21F1091. So here is some of the content that we present today. So let's get started. So this is our team role and responsibility. I, as the leader, my responsibility is to ensure all group members participate and divide the task to the group members equally, and communicate with the members and keep the group members aware of the time constraints and deadlines. And the secretary of this group is Shoban Rao, son of Iswara. His responsibility is to take notes and summarizing team discussion and decision and keep all the necessary record. Ensure the group members focus on most important issues and doesn't get caught up in details. So for our innovator, we give it to Muhammad Haikal Hakimi bin Desa. His responsibility is to strive to create harmonious and positive team atmosphere. Other than that, he's encouraged imagination and contribute new alternative perspective ideas. He also responsible to fill the missing members whenever needed. So Muhammad Azmi will be our helper in this group. Because of his accident last week, he is not be able to record a video to present it. Next, I will introduce you to differentiation. What is differentiation? So differentiation is used widely solving problems, especially in engineering, medical, agriculture, and many other fields. When you find the rate of change of quantity with respect to another quantity, you are actually doing a differentiation. So another name of differentiation is derivative of the functions. So gradients equal to change of vertical height divided by change of horizontal height. So it's generally to find differentiation of y with respect to x, just write the symbol of dy over dx to represent it. So without wasting any time, let's know some of the basic rule of differentiation. Okay, so for the first thing I want to present to you is the basic rule of differentiation. So as you can see in this slide, I put the example how to differentiate the equation. So we got y equal to x power of 3 and we differentiate it. We got dy over dx equals to 3x power of 2. So hear me out. It's very easy, guys. We just the power times France and then the power minus 1. That's all. And then it's very easy. Okay, so next is product rule function. Product rule function is the derivative of product of two functions times the derivative of the second plus the second function times of the first. If you don't understand what I'm saying, just look at the example of not example, it's a formula. Yeah, just look at the formula. So the product formula is dy over dx equal to v times du over dx plus u times dv over dx. Okay, so this is the example of the product rule function works. You just have to follow the flow, and then I'm sure that you also will be good in this differentiation and how to use product rule function. So the next that I want to present to you is the quotient rule. In other words, quotient rule is the derivative of quotient in the denominator times the derivative of the numerator function minus the numerator times the derivative of the denominator divided by the denominator square. So if you don't understand what I'm saying, so you just see the formula. So it's dy over dx equals to v times du over dx minus u times dv over dx over v square. That's all. So this is an example of the quotient rule. It's different than the product rule because Quotient rule can be used only when the number have the fractions. So how to use it? You just have to follow the flow. So the next function is trigonometric functions. As you can see, it's very have many rules. That's why you have to memorize it all, because if you don't memorize it, then you can't answer the questions. So this is an example of the how we use the trigonometric functions rule. Yeah, as you look closely, it's very tricky, but I think you might be able to do it because if you memorize it properly. Okay, so for the last rule is chain rule functions. You might be able to think that this function is easy, but you must be careful about the how to find the value of dy over du and du over dx. Yeah, so this is an example of the chain rule functions. If you look closely, you must think that this is easy than the previous one. Yeah, I agree with you, but you have to be careful when you want to find the dy over du and du over dx. That's all from me. Thank you.
Next, my name is Muhammad Haikal Hakim Ibedeza and my metric number is 01DKA2C. Now, I'm going to discuss about application of differentiation in real life. The example of real life application of differentiation is differentiation is very important in many fields and has made great contribution in this field, which are still noticed nowadays. In economics, differentiation can be used to calculate the rate of change of the ordering and transportation costs for the component used to manufacture a product, in which the cost is dependent on the order size. The first example is coffee maker. In the process of making coffee, coffee is draining from a conical filter into a cylindrical coffee pot at a rate of 10 in 3 minutes as usually. Second, consuming gas mileage. Gas mileage of an automobile is affected by many factors like road surface, tire type, velocity, fuel octane rating, and the speed and direction of the wind. The effect of the velocity on the gas mileage of a certain car is expressed in the function below. The third example is calculus speed trap. 3 students use a distance measure app to measure the distance between the gate of the school on the road, which was found to be 78 meters. One of the students extended his arm and followed this road passing cars until it hits a 45-degree angle. The other 2 students timed how long it took for each passing car, average the time. The last example is response of a plant to daylight changes. In London, the number of hours of daylight can be found using L in bracket T equal to 12 minus 4.5 cos in bracket T, where T is the time measured in unit 2 corresponds to 1 year. A certain plant unfolds its leaf in the spring in response to change in day length. That's all for me. I pass to the next presenter.
Good morning, sir. I'm Shobhan Rao, son of Viswar Rao. Number matrix 01DKA21F1092. And I'm here to explain about the solution of the question we got, which is the graph of a curve with equation y equals x cubed plus 3x squared minus 9x plus 6. Okay, the first question was use differentiation to find expression for gradient of curve in common dy over dx. And I got 3x cubed plus 6x minus 9. And the second question was find the coordinates of any stationary points on the curve. And the first one I got is 1, 1, and another one is negative 3, 33, the coordinate. And I got that by using which is stationary point dy over dx equals 0. And I used the first answer, which is 3x squared plus x minus 9 and equals to 0, and I just did a small fraction simplify, and I got x equals to 1 and x equals to negative 3. With that, I substitute the x to get y value, which is 1 and also 33. In x1 I got y1, and in x negative 3 I got y33. Okay, then over here the third question was how many stationary points does the graph have. In my calculation I got 2 stationary points, which is 1, 1, and another one is negative 3, 33. Okay, D, determine y-intercept point. In y-intercept, x must always be in 0, and from there I got y equals 6, and the coordinate was 0, 6. Question E is determine the nature of any stationary points you found in part C, justifying your answer. The nature, to determine the nature, I did d square y over dx square, which I got 6x plus 6. In this equation, if x I substitute with 0, I get d square y over dx square equals to 0. And over there you can see that I did a table which I just substitute x with negative 1, 0 and also 1. In negative 1, dy dx I got the negative value, 0 I got negative value, and 1 I got 0 value. So down there you can see the line which is negative from right to left, from left to right is going down and going down and going straight, and that's how we got the graph. Okay, and that's all. Thank you. And over here you can also see the graph point, which you can see the graph point. Okay, over here you can see the 3 graphs. I construct 3 graphs from this question. The first one, which is in red color, is the graph for y equals to x cubed plus 3x squared minus 9x plus 6. And the second one, which is in blue color, is the graph for dy over dx, which is 3x squared plus 6x minus 9. And the one in green color, the straight one from left bottom to the right top, it's the d square y over dx square graph, which is 6x plus 6. And that's all from me. Thank you.